of the quadratic formula. And what I decided to do today was I wanted to do the proof just to show you how it goes and to show you why the quadratic formula is how it is. So right here, I've got the standard quadratic equation. It's ax squared plus bx plus c equals 0. As you know, x is going to be the variable, and a, b, and c are all real numbers. And we're going to add the stipulation that a cannot equal 0 for obvious reasons, right? If a was 0, this whole quadratic term right here, this ax squared, would equal 0. So we're not going to let a be 0. But b can be 0, and c could be 0 as well. So let's start there. Okay, so we know that ax squared plus bx plus c is equal to 0. So what we're going to do first is we're going to subtract c from both sides. So I'm going to subtract c from both sides and see what happens. So we have ax squared plus bx is equal to 0 minus c. That's going to be negative c. Okay? So now the next thing that we're going to do is we're going to divide everything by the leading coefficient, which is a. We're going to divide both sides by a. That means everything on this side has to be divided by a, and everything on this side has to be divided by a. So let's go ahead and do that. I divide everything here by a, and I divide everything over here by a. So now what do I have? Well, here, these two a's are going to cancel out, right? So I'm only left with x squared plus, bring down my plus sign, and over here I have b divided by a. B divided by a times x equals negative c over a. Okay? So now I'm at the point where I'm ready to start doing what's called completing the square. And completing the square is the part where you take the linear term, you take the coefficient out in front, and you divide by 2. So I'm going to bring this over here, and I'm going to divide it by 2. So if I take this b over a and divide it by 2, I'm going to get b over 2a. b over 2a, right? And then after that, what I'm going to do is I'm going to square it. I'm going to square what I just got. So I'm going to take that b over 2a, and I'm going to square it. And what happens when I square this term? I square the top to get b squared, and then I square the bottom to get 4a squared, right? Because when I square the 2, I'm going to get 4. And when I square the a, I'm going to get a squared. So this is actually going to be the term that I'm going to put a red box around. I want to add this to both sides. I want to add it to both sides. Okay? So, given the equation that I have right here, I'm going to add this term to both sides. So, what is that going to look like? Well, I'm still going to have my x squared. I'm still going to have the x squared. And I'm still going to have this b over a times x. And then if I add this, I'm going to have b squared over 4a squared. And it's going to equal negative c over a plus, and then I got to add this to this side. So it's going to be b squared over 4a squared on this side. Okay? So now what I'm going to do is I'm going to complete the square on the left side, and I'm going to do some common denominator stuff on this side. So let's stick to the left side for now. What I'm going to do is I'm going to take this divided by 2 term, and that's going to become what's inside the parentheses when I complete the square. So when I complete the square, I'm going to have an x right here, and I'm going to have a plus b over 2a. b over 2a. I put the whole thing in parentheses, and I square the outside. Okay? So it turns out, if I FOIL this with itself, I'm actually going to get this back. So this step is accounted for when I complete the square. Now, over here on the right side, What's going on over here? Well, I've still got that b squared over 4a squared, and I've still got a minus c over a. So what I'm going to do over here is I'm going to find a least common denominator. A least common denominator. And that basically means I'm trying to find the same denominator on this side. So what I'm going to actually end up doing is I'm going to multiply both sides of this fraction by a 4a. And we'll see that in the next step. So over here, I've still got my x plus b over 2a. The whole thing is still squared, right? And then over on this side, what's going to happen? I'm going to keep this fraction the same. So I'm still going to have b squared over 4a squared. But then over here, I need to find that least common denominator, so I'm going to multiply the top and the bottom by 4a. So I'm going to get 4ac on the top, and I'm going to get 4a squared on the bottom. So now, notice how the denominators are the same. I can actually write this as one fraction. So continuing on down, the left side is still the same, so let me write that out. The whole thing is still squared. And then over here, I'm going to write these two fractions as one fraction, since the denominators are now the same. Okay? Alright, so now I want to get x by itself, which means, first of all, I've got to get rid of the squared term. So how do I get rid of a squared term? I actually take the square roots of both sides. So if I take the square root of this side, the square is going to go away. And I'm only left with x plus b over 2a. So I took the square root of this side, but that means I also have to take the square root of this side. So I'm going to get plus or minus the square root of b squared minus 4ac over 4a squared. And now I'm starting to run out of paper, so I'm going to grab my next sheet. And then what we're going to do is we're going to get rid of this b over 2a. We're going to subtract it from both sides. Okay? So, let's go ahead and subtract b over 2a from both sides. And I've also got to subtract it from this side too. So when I do that, what's going to happen is I'm going to have the left side just being equal to x. So I'm going to have x equals negative b over 2a plus or minus the square root of this big old fraction, b squared minus 4ac on top, and on the bottom I have 4a squared. And now, since I have the square root of a fraction, I can actually break up the square root into a square root on the top and a square root bottom. So continuing with this, I still have x on this side, I still have negative b over 2a, I still have my plus or minus, but now I can actually write the top as a square root, I still have b squared minus 4ac, and then I can write the bottom as a square root, where I have 4a squared on the inside. Okay? So the last thing I'm going to do is I'm going to take the square root of 4a squared, and we know that that's going to be 2a. But this fraction is going to stay the same. The top of this fraction is going to stay the same. B squared minus 4ac under the square root. And then what's the square root of 4? That's going to be 2. What's the square root of a squared? That's going to be a. So now, notice how I have a common denominator at the bottom. So I can actually write the whole thing as one fraction with a common denominator. So what's going to be on top? I'm going to have that negative b plus or minus the square root of b squared minus 4ac, and everything is divided by 2a because that's my common denominator. And I'm done. So this is called the quadratic formula. The quadratic formula. And you can use this formula to solve any standard quadratic equation. So that's the proof, that's how it works. and I hope I help some people out with this. We'll see. So that's it. That's the proof.